Okay, good afternoon. We'll make a very rudimentary very simple game for this lecture. No, for this lecture, I'll just introduce very basic scripting as well as user input. Our goal or the thing that we're going to make is here. No, clear, Masha. I think. If you can't see, maybe you can move forward a bit. Um, but I just have a few shapes here. 2D ni siya. Just to be clear, no, this is 2D, but we'll be doing 3D later on. Just for this introduction, to simplify things, we'll be using 2D environment. So I have here just a square, circle, and a capsule. So for this one, our capsule is going to be the one that is user controlled, and it is going to interact with the square and the circle. So this is very simple. If I click on play, right? So we're going to the game scene. Now, if I click on W or not click on, if I press W and S, our capsule goes up and down, right? And then if I press A and D, so it rotates. So umala na siya. That is our uh, user input, and then it interacts with the other objects. Like you can push it around, and it affects you as well. Okay, so this is very simple lang siya. Just to introduce you with basic scripting, very basic scripting as well as user input. Okay, I'll close this. So if you haven't, please create a 2D na project sa Unity, and then we'll start. I already have one open here. Okay, so it starts off like that, right? A very basic window. Okay, so if we click on the game scene, there's nothing here yet. It's just all blue. Okay, in the scene, we just have a camera. So we could zoom this a bit. Sorry, plug the mouse. All right, anyway. Okay, so there's nothing yet in our scene, just a camera, no? And if you click on the camera, there's nothing in the camera yet, just the blue background. So what we'll do, we'll create elements here. So to create an element or a game object inside our scene, we could right click on the hierarchy here on the left side. And then since we're doing 2D, so we're dealing with 2D objects, I'll select sprites and I'll add a capsule. So you can choose, no, if you don't want a capsule, maybe you could select a rectangle or a circle. That's up to you. I'll reset the transforms to make it centered, but actually I will move it a little bit here downwards. Okay, so now we have a game element. If we click on play, uh, there. It's just a capsule inside the blue screen, right? So we'll create a bit of behavior for the capsule. This is very easy. We are going to create a script, a C-sharp script. So this is an introduction to C-sharp scripting as well, no? There are ways to create a C-sharp script, but what I usually do is the assets. You have there the basic assets with the scenes, and to keep things organized, I create a folder under the assets folder. So we could right click and then create a folder, and then I'll just name it scripts, right? And then inside the scripts folder, I'll create a C-sharp script there, C-sharp script. Now be careful when you're creating a C-sharp script. The very first name that you enter for the script will also be the class name of the said script. So if I just leave it as new behavior, right, it will there. So new behavior siya, new behavior dot C sharp, right? And then you will click, not click, you'll see a preview of it here. Okay. Uh, so let's open its VS Code so it's clearer. There. So public class new behavior script. So that is the name of the script. So if you want to rename the script file, then you also have to rename the class of this script. So for example, you made a mistake. So let's delete this for now. Right? So for example, we create a script, and then I say capsule, something like that. But I made a typo, and then I want to rename this. Oh, oops. I want to rename this as capsule with an E, right? Pero hindi siya mag-change. This, the class name inside the script will not change. So you have to edit the file as well. Capsule, something like that. So yeah, be careful if you're not yet sure what to name, then don't press enter yet, right? Sige. We'll leave this script as capsule. Actually, no, let's create a new script para it's a bit more descriptive. Sorry. Yeah, let's create a script called our capsule behavior script. So this describes the capsule's behavior, right? Opening this script, we will see we already have the um, necessary na this is not really imports using in C sharp is like a namespace. So we don't have to do unity engine dot this, unity engine dot that. We could just call functions from unity engine. So basically namespace siya, right? Um, sa Python, if you're using Python, it's something like import numpy as np. Yeah, that's like that. Okay, but we have two functions here. We have void start and void update. So comments man siya, right? There is start is called before the start of the first frame update. Actually, start is being called whenever your object is instantiated in the game. So it will do everything here sa start na function once it is instantiated. In our case, right, if we put it in the capsule, when we play the game, since the capsule is already there, once the game starts, it will also call the start function. So if you have necessary setups, right, before the object does anything, you could put it into the start. For now, we'll leave it as is, right? We'll leave it blank as is. What we're more concerned here is our update, okay? Our update na function. Our update function is called every frame. So when you go to the next frame, if you're playing a game, right, it's the next sort of state or next frame of the game. Every time the frame changes, our update function will also be called. Okay, so let's decide on the behavior of our capsule. For now, right, I want our capsule to just go up, right? Like that, like go up, right? So what we want to do here is actually change the, if we look at the inspector here, we want to change its transform, right? So if it's going up, you see Y here, so position also increases. If it's going down, Y here decreases, right? So what we want to do is just sort of move the capsule up for now. So to do that, since it's transform, we want to call transform and access the position itself, right? We could just say transform here in update. So transform. When we say transform here, note it's small letter t. If we're using it inside the script and transform, it means the object, this component. Treat your components as objects inside the objects itself, right? So the transform object, we will call the function translate. So translate is going to add or move our object depending on the argument we pass to translate. So translate uses or accepts a vector. I don't know if you remember vectors physics, but it's a direction of force or something. Basically, it's three values. One for x, one for y, and one for z. Now, if you remember, we are going to move in the z-axis, right? Or the y-axis rather. So we could just supply here new vector 3 and then plot in the numbers here. So if we want to move in the y-axis, so we could put x as 0 and then 1 for y and then 0 for z, right? So what this does is we get the current transform and then we add 0, 1, 0 every frame. So here, right, mag 0, 1, from negative 3, mag-add kita 1, sa y, mag-add, mag-add, mag-add. That's the translate. Okay, so let's save this, and then let's add the script itself to the capsule object. Now, there are a lot of ways to do that. You could add it here through add component, and then maybe you could search for capsule behavior there. There, it's added to, this component is added to the capsule object. Or if you don't want that, we could remove this, right? Or we could do, we click on capsule and then click and drag derecho C script here, right? You could also do that. You could also do, so remove component, click and drag here, diretso sa game object. That is still adding the component here. So what I usually do is I click on capsule and then add the script as component. Okay, so let's save this and then let's try um, doing it in play mode. So our expected behavior is ang capsule just goes up, right? There, it went up. It's very fast because, well, every frame it adds one to our capsule here, the Y position. So maybe we could turn that down, right? Maybe we could declare a variable here, say private float, let's say forward speed, right? And let's make it around 0.01 f, right? So we could do, so instead of 1 here, we could um, supply our forward speed, like so. And then let's go back to Unity and test it out. Okay. There. So slower na siya, but we don't really have controls over it. It just goes up and up and up until it's out of the screen. Okay. So we can adjust the speed of it here, like edit the script and then go back, edit the script, go back. But a better way to do that is actually expose this variable since it's private, right? You could expose this variable to the inspector, right? There are a lot of ways to do that. You could set this as public, but I don't really do this often since it's not really, it doesn't follow encapsulation in my head. So I just keep it private, and instead of making it public, I expose it just to the inspector. I add sort of a property here, serialized field. Okay, so this is a serialized field. This is still private, so we can't access it in like other scripts, but we can access it through the inspector. Okay, if we go back to Unity, we click on capsule. Under the capsule behavior script, may kita the field forward speed. Now we can adjust it here, right? Maybe I want it a little more, a little slower than before. So I put it 001. So there, it's much, much slower. We can edit this as well, no? During game, right? There, so it goes up, it goes down, like so. Okay? Just take note that any edit that you do during the play mode is not carried over sa scene mode. Okay? In this case, my 0.001 here, right? It overrides the value that we set here. So kung ano ang naset here sa capsule na object, that is going to be the one followed. Okay? Let's clean up a bit before we proceed to some other things. This new vector 3, actually, we could rename this, right? Or we could do this. We could create a, float here. Um, forward movement. Actually, let's do vector 3. Okay? So what we could do is use pre-made vector 3 na mga uh, values. So for example, vector 3, if we're going positive y direction, that is essentially sa 2D environment, that is up. So si vector 3, there are a lot of static siya na values such as vector 3 dot up or vector3 dot left, or vector3 dot forward, etc. The one we're concerned here is y-axis, so we'll do vector3 dot up. So if we look at ang tooltip, actually this is shorthand for writing a vector 3 that is 0, 1, 0. Right? So that creates a vector 3 that's 0, 1, 0. And then we'll just multiply that vector 3 with the forward speed. Okay? So what that does is, multiply ka lang sa 1. So whatever the value of your forward speed will be, amo na siya ang sa up. Okay? And then, instead of the vector 3 here, we'll rearrange that as forward movement. Okay? So that will just do the same thing if we do that. Yeah. So still the same thing, right? Very, very slow. Okay. If we rotate this, say we rotate in the z-axis, there, it follows na it's not moving in the y coordinate as a of the world. It is moving to its own y coordinate. So if we look at sa scene view, actually, ang y coordinate ni capsule also rotates with itself. So ang y coordinate niya goes here, right? So that's why if you translate +1 +1 +1 or plus the movement value, it just follows that direction. Okay? If we move here, right, it still follows that direction. Following, may pa? Right. Uh, since we have forward speed na, we let's have probably, I don't know, rotate speed for like steering, right? So we could do another field here. I'll just say this is turn speed. Uh, Maybe I'll put it around 10. Okay, and we'll use this for rotation. So for rotation, we're not going to use translate. It's another function naman. But let's observe first what direction we are going to turn to, right? So if we rotate along the x-axis, there, I'm gonna show rotation niya because essentially you're rotating it sa plane sang x. So it goes sort of inward um, to the screen. So we're not really going to use this x-axis. Y-axis, it is doing this. So again, it looks thinner, but it's actually rotating since this is a 2D object, right? It's actually rotating sort of inwards. So we don't want that. What rotation we want is here, sa z siya na axis. Okay? So if it's positive, positive na value, it turns to the left. And if it's negative, the value turns to the right. Okay? So that's what we'll use. That's the information that we'll use to rotate. Okay? So rotate, we could do transform dot rotate. Uh, and then there's another vector 3 here, the value. So maybe we could do the calculation here. Turn, angle, maybe. And instead of vector 3 dot up, we want 0, 0, 1, right? 0, 0, 1, the shorthand for it is, I think, forward. Yeah, vector 3 dot forward. So there's 0, 0, 1 because we're turning in the z-axis, right? And then instead of forward speed here, we'll do turn speed. There. And then we'll just supply turn angle. Okay. Um, I will move our capsule here because I know what's going to happen. If we click on play, there, it's very, very fast. So we could reduce the turn speed to like 1 there. And maybe we'll pump this to forwards. Oh, there. Okay, it's done. Yeah, But we can adjust it. Maybe this is 1. Maybe we could do 5, 0.05, 0.005. Save this, run it again. There, it's sort of rotating around a point. If I put like 0, 0, oh, oh, yeah, it's zooming. Let's say 0.1. Okay. There. So rotate lang siya, revolves around a certain point because it's moving forward as well as it's also turning every frame, right? Yeah, basic behavior lang siya sa capsule. Wala pa kita player input, but let's adjust a few things though. Okay, so currently there's actually a problem with this setup. Okay, uh, which I'll show you sa game scene. There's actually a problem with this setup currently. Now, if you view it like this, it's fine, right? It doesn't seem like there's a problem. If we inspect stats, you'll see sa graphics there is this FPS, that's frames per second. Now, if you remember, the na update na function is called every time you go to the next frame. So if your computer processes frames differently from another computer, then ang movement of our capsule will be different. So if say my another computer runs this at 1,000 frames per second, then it will spin faster. If another computer processes it in a lower frames per second, it will be slower. Actually, let's try that. I will open another project here. It will affect my processing, and you'll see the FPS drops actually. And you will also see that the capsule slowed down a bit. Yeah, there. When it dropped to around 120 FPS, you actually would see that it is getting slower. Okay. So that problem is what you would call frame rate dependency, right? That our game depends on the frame rate of the system. If we're doing games such as this, we actually don't want that our game is dependent on the frame rate of the system that we're running on. That's why some games sort of cap their frames per second to 60, some at 30, etc. But what we can do is to sort of liberate that constraint, liberate our processing from that constraint by having this value called time dot delta time. Time dot delta time. Okay. So this is how you would use it. We multiply time dot delta time. I'll tell you what it is later. We multiply time dot delta time to our translation or translation function. So move forward, we multiply time dot delta time. We also do it here, time dot delta time. So what is time dot delta time? If you look at the tooltip, it says the interval in seconds from the last frame to the current one. Basically, the time it takes from one frame to shift to another frame, right? So, for example, your system runs at 100 frames per second. So ang time niya is 1 second divided by 100. So that's time that delta time. So for example, our move speed is 10. This is just a random calculation, right? And then our FPS in our current system is 100 FPS. So that's 1 second over 100 frames, right? And if you multiply this, then the movement will be equal to what? 0 0.1? 0 0.1 every time, right? Every frame siya na yeah, wait. 1 over 10. Yeah, yeah, tama, tama. So every frame it will move 0.01 units. So in 1 second, it will move 10 units, right? Now, if your system runs on a lower specs, lower frames per second, say our move speed is still 10, and then say instead of ang FPS ta is so multiply by 100 because 100 frames in a second, right? Let's say our system runs in a very low 20 frames per second, so that's 1 frame per 1 second over 20. So that's actually the time, right? So we will have, what's the value of that? 2, I think? No? Yeah, 2, right? So if you, no, not 2, sorry. Calculator. Zero point 0.5, yeah, zero point 0.5, sir. So point 0.5 units siya every frame a move. So if you have that movement times 20, since there are 20 frames per second, you'll get 10 again. So even if you have 100 frames per second versus 20 frames per second, we are liberated by that constraint. Hindi na kita frame rate dependent. So let's see, no, if we multiply this with time that delta time, let's see how it behaves. Click on the capsule. So it's now very, very slow because time that delta time or that time between frames for this example is very, very fast. Actually, it's like 300 frames per second, right? So we could adjust this. Maybe our forward speed we could do 10, and then for our turn speed, let's reset it. So forward speed maybe around 10, turn speed maybe around 60. Okay, so we could adjust those things and then see if it's there. It's still a bit big. Maybe I'll do the turn rate around 150. There, better siya. Right. Then and then this is 150. Okay, so our capsule now moves like that. So even if I sort of open another project, say I'll open 2D platformer here, so that if affects my frame rate, right? But it doesn't affect the movement of the capsule. So free na kita by the FPS na constraint, right? Very fair. There. So yeah, basic movement, basic scripting. I'll just close the other one. Where is it? Let's compile it. Well, now, so we have basic thing, but we can't really interact with the object for now, right? What we want to do is, well, try to interact with the object. I'll reposition it here. Let's talk about user input now. For Unity, there are a lot of ways to provide input for the game, right? You could actually listen for exact keys. Like you could listen for key down D, key down A, key down W, something like that. But there are better ways. Um, uh, One way is to use the input manager. To access the input manager, we'll go to edit and then where is it? Project settings. Okay, and then here find input manager. Okay, under input manager, you could find it here axis. So these are the axis of movement. What we're interested here in currently will take vertical axis and horizontal axis. Let's take a peek at vertical for now. Okay, so this one, so there is a name, vertical, right? And then we have buttons here, up and down. So the positive button is up and the negative button is down. So basically, we have three values that this axis could have. If you're pressing W, this axis will have a positive value. So plus 1 siya. If you're pressing down, this is negative value, that's negative 1. If you're not pressing anything, that is 0, right? So three values siya. We can then use this axis to multiply it or make it as a multiplier sa atin ng movement, and then we'll see differences in movement later on. We also have alt negative button, so you could have up arrow, down arrow. Also, S for negative and W. So this will take care of even if you're using arrow keys or WASD, same siya. Same siya gyapon nga axis ang ma-affect, right? You could actually also, um, sorry, use this with a controller. So I brought a controller here for the demonstration lang. So I'll plug it in. Because it's listening here. Joy num there. It's getting a motion from all joysticks. Okay. So let's use this as script to get that input manager. Say float vertical input. To use that, we could access it from input. Your input and then dot get axis. And then we'll supply the name of the axis here. So we're interested in the vertical axis. This is actually a string siya na ano, input there. So get axis vertical. So we're taking the input from the input manager in the vertical axis. So we'll just multiply this sa forward speed. Let's say I'll multiply it here. So it's now this. So it's now vertical vector 3 up, which is 0, 1, 0. We multiply it with our vertical input, either 0 or 1, 0, 1 or negative 1, and then the speed, and then time that delta time for that frame rate na issue. Okay, we'll move our capsule a little bit over here. Okay, let's try this. Ang input. For now, currently, I'm not pressing anything. So ang input from the vertical axis is 0, right? So if I press W, 1 ang input, so it moves forward, like so. Right? If I press the S, well, it looks the same because medyo wala difference sa tsura sa capsule, right? And the capsule is lost. Get back in there. Right. So if I press W, it moves forward. If I press S, it moves backward. That's actually backward. But I could also use the arrow keys if I move. This is up and down, right? You could move it with up and down. You could also use your controller. It's this joystick in particular. Uh, let's move this one here para makita. Right? This joystick in particular, if I move it up, there. So, we didn't listen for the exact na key, right? It accepts input from W and S, as well as the arrow keys, as well as the joystick. Okay? You can also do that for vertical and we'll tie, no, not vertical, horizontal, and we'll tie it with the rotation. Okay, so take a peek at that. Project settings. So for horizontal, that's left and right arrow keys or A and D. Okay, and we also have here from all joysticks. Okay, so to get that, we could, I'll copy this float instead of for hors input. Okay, and axis is horizontal. Take note this ang string input here, this is case sensitive. So if you put small letter V, and then yan na siya makuha. Okay? Horse input. And then we'll do here. Times horizontal input times time that delta time. Okay? Now, we can control ay, turn speed. Oh, man. Huh? Ah, sorry. Just save the, ano no, you just save the C sharp files tapos si Unity na ang makompile. Now we have total control sa movement of our capsule. If I press up, no, it goes up and down. If I move it here, so yeah. Just a thing here, if I move the joystick to the left, suli ang rotation. Because this is our negative button, right? But if we observed earlier, here, if we go to the left, positive change, yeah. If we go to the left, positive change to the left siya dapat ang rotation, and if we go negative to the right siya dapat. So we could just invert that, right? We could just multiply it with -1. So multiply it with yeah. So yeah, okay na siya, right? We just inverted it. So up, down, and then rotate. Yeah. Okay. Now we have player input. Let's add a few more elements to our game scene to have, interaction. I'll save the scene for now. I'll add a few more shapes. So I'll add a square. Where's the square? Okay. Square here. Move it around here. And then maybe I could scale it bigger. So, and we could also change the color here sa sprite renderer. Color, maybe I'll color it red, like that. So sa game screen, looks like that. Actually, no, for you're developing later on, you could lock this aspect ratio 16 by 9 or 16 by 10. You could lock the aspect ratio here because if you don't lock the aspect ratio, then dependent siya sa, if you don't lock this, naka-free aspect siya. So, depende siya sa size ng screen mo, ga-expand man siya and contract. So, I usually do 16 by 9 aspect ratio because that's the aspect ratio for most screens. Um, what I do usually know is I separate the game screen from the scene view. Or if I move something in the scene, right, I could still, I could still see where it is in the actual game view. So if like it's outside the scene view, it's over here. Amo na siya ang visible part niya sa camera or sa game view. Okay? Or we could also add another object, a sprite, let's say a circle. There. Let's make this bigger. Bigger. There. Move it here. Let's change its color to, say green. Okay. So now we have two more elements. So let's see how it plays out. Put this one here. Okay. So let's see how it plays out. If I enter the square, nothing happens. Enter the circle, nothing happens. Well, because there is no interactions yet. If we want collisions, we add colliders, right? So if we add colliders to these, actually, if we want the capsule to collide with the others, so both parties should have colliders collider na component. So to do that, we could click on our capsule here, and then under add component here, you could select for collider. Wrong spelling, collider. You have a ton of choices with collider, but the closest shape to our capsule is capsule collider. Now there are two choices. There is a capsule collider that is 3D. Okay, that's a 3D collider, and this one is a 2D collider, right? Ang difference man lang with 3D and 2D collider is ang collision for 2D, as long as magmatch ang ilang X and Y, right? It's a collision. But with 3D, there is the z-axis pa. Okay, for 2D games, wala masyado gina-take into account si z-axis. So for this one, this example, since this is a 2D environment, we'll do Capsule Collider 2D. There is another checkbox here is trigger. So you could differentiate it from an actual collider and the trigger. We'll just talk about triggers next time. But for this use, just leave it blank. And yeah, it's set. If we zoom into the capsule, I'm not sure if that's visible here, but if we zoom into capsule, there is a fine, very fine green outline. That is the collider. Um, we could expand that by editing the collider. We could click on this one. That's the edit collider. And then you'll see a few knobs here, like very small green dots, and you could move that around to there. That's the actual collider, right? So you could modify the hitbox of our capsule. For now, if you apply a capsule collider to a capsule object, ang fitting na siyang shape. So I won't really edit that collider for now. Okay. But since we want collisions, di ba, both colliding parties should have colliders. Okay? So for the square and circle, for the square, I'll add a square collider or a box collider 2D there. And then for the circle, I'll add a circle collider 2D. Okay, like that. So let's test it out and see what happens. Okay, so A, up, down. So I'll rotate towards the square. Why doesn't it collide, right? It's not colliding. So the problem here, or the issue here, or how do we fix this is there should be there. This is the rules. Collisions and triggers with Unity when you're using Unity is that whenever there is a collision, you want to detect a collision. Either party, so either just one of the parties or both of the parties should have a rigid body component, right? Rigid body. So in this case, rigid body 2D siya because we're doing rigid body. Rigid body is also responsible for your physics na mga elements later on. If we introduce force, if we introduce gravity, rigid body will be the component that is responsible to interact with those forces. So let's minimize the other stuff here. Since our capsule is the one moving around, right? It makes more sense that the rigid body is for the capsule. And well, these two static lang siya. Okay? So we could attach a rigid body 2D. Again, since this is a 2D environment, we do rigid body 2D. Okay? There is a body type here. So there are three, dynamic, kinematic, and static. So dynamic meaning this could change. It is affected by gravity and other forces such as, well, collision. Static, kinematic is it's not going to be affected by physics. And static, well, pwede siya ma-affect by physics, but it doesn't move. Okay? For now, since we want our capsule to affect, no, to move around, so we'll set it as dynamic. And then we have mass settings here. So if you want no different weight of objects, you can set this. You have like simulations, etc. And another important thing here is gravity scale. Gravity scale is if it's going to be affected by gravity or not. So if I play this, well, since I know what's going to happen, let's put it around the top. Okay, right? If I click on play, it will now be affected by gravity. It will fall. There. So you can counteract by pressing W, but gravity too strong. Okay, there. It falls to wherever, to the ground. Okay? So what we do, instead of gravity scale 0 here, we don't want gravity to affect our capsule. So we'll let our capsule defy gravity by making our gravity scale to 0. Now it's going to fly. Okay? So now it has a rigid body. Gravity scale is 0, so it won't fall down, right? So if I go up and down, still going up and down, I'll rotate towards the red, and now it it doesn't go through. So it bumps to the collider, and then, well, physics just says na mag-slip off lang siya, right? Wala siya gakapit. There. If I bump to the circle, there. Hindi siya. Yeah, I'm just pressing W. It's just the physics engine doing the thing, right? Na I can't pass through, so it deflects the capsule. Like so. If we want na our circle and square is also affected by physics, or it can also move, no, with physics, we could add rigid body 2Ds to those as well. You could do this for multiple game objects now. Just select the objects. You could click individually, hold control, and then click individually. You could also hold, click shift like that. Basically, you're selecting multiple game objects here, and since we're doing rigid body for all of them, you could just click add component and then rigid body 2D. Now we don't want these two to fall as well, so we'll disable gravity by indicating that gravity scale is 0. Okay, and we could edit the mass as well, etc. But let's just check it out how it functions for now. Okay, if I bump into it, move naman siya. Since may rigid body component na siya, it's affected by physics. There. If you adjust the mass of this one, let's put it here. If you adjust the mass of this one, say 100 ang yung mass, right? There. So hindi mo siya ma-move. Kaya ang capsule tayo is just 1 ang iyang mass. There. So yeah, it follows rules of physics or simulated physics. Yeah. So basic lang siya, right? Basic rigid body component, translate and rotate, player controls. Next meeting, we'll do 3D na siya, 3D environment, and yeah, we'll see how you could add like objects in a 3D environment. It's much more complicated than 2D, pero you know, follow around. Okay? Any questions? None so far. Easy pa lang man, no? So if you don't have Unity, install na kami Unity. And yeah, that's it. That's it for this lecture.